Part 1. Descartes' rule of signs. Alright, last week when we learned the rational root theorem, it was kind of, it narrowed our guessing down, but it was still a pretty big list of numbers to guess from. Do you agree? Yes. It's better than just randomly guessing an infinite amount of numbers, but still a big chunk. So today we're going to try to narrow that down even further. Alright, so Descartes' rule of signs will help us find the number of possible positive, negative, or imaginary solutions. Alright, so how do we find it? We will find the number of possible positive roots. Number of possible positive roots. The way we will find that is we will use our original f of x function. So we're going to be given an f of x function. And we're going to look at that f of x function and look for the number of sign changes. Why it's called Descartes' rule of signs. We look for the number of sign changes. Alright, right now you may be like, what the heck does that mean? When we go through an example, it'll make a little more sense, and I'll go through and I'll explain as we go what it means. Let's write the next one down, how we find the number of negative, and I did forget the word possible. Possible negative roots. Any guesses at what we look at? Still going to look at sign changes, but instead of f of x, any thoughts? F of what? F inverse? Good guess. Anyone else? We will use f of negative x. We will use f of negative x, and same thing, and look for the number of sign changes. Alright, imaginary solutions kind of just work their way out from these two. Once these two are done, imaginary solutions work their way out, and we'll talk about it as we go. Alright, so let's take a look at an example. I want you to list the number of possible positive. Austin, are you taking notes with us?
Yeah.
Okay. Negative and imaginary. Solutions. Alright, so right now we're just going to list the number of possible solutions. That's it. We're not going to do anything else past that. We will see some examples in just a bit where we actually use that to help us find our solutions. Alright. Number 1. F of x equals 3x cubed minus 5x squared plus 6x minus 4. Okay. F of x equals 3x cubed minus 5x squared plus 6x minus 4. All right. Let's take a look at, first off, what's the degree? 3, which means how many possible solutions? 3. No more, no less. All right, so number of sign changes. Okay, so this is positive and it changes to negative. That is one sign change. It changes to positive. That is another sign change. And then it changes to negative, and that is another sign change. How many sign changes? Number of sign changes equals what?
3.
3. All right. Now we're going to find f of negative x. And that means we do what to all of the x's? We plug in what? A negative. We plug in a negative x and see what ends up happening. All right, negative x cubed. Is it going to be positive or negative 3x cubed? Negative 3x cubed minus 5x squared or plus 5x squared? Minus. Why do these two negatives not cross out? The squared. Right, you do the square before you multiply, correct? Exponents first. All right, plus 6x or minus 6x? And then plus 4 or minus 4? All right. Negative, 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 negative. How many sign changes? How many?
2.
2? 1? None? Anyone else?
None.
None? Anyone say 1? 4? There are none. All right, because negative to negative, that does not change. Stays negative does not change, stays negative. They stay negative all the way throughout. So how many sign changes? None, 0. All right, so here is how you're going to write your answers for these type of problems. Positive equals blank, negative equals blank, and imaginary equals blank. All right, it will always decrease by 2. Our solutions will always decrease by 2 until you get to either 1 or 0, never on the negative side. All right, so how many, we said here, for the number of possible positive roots, we use f of x and look for the number of sign changes. How many sign changes did we have? 3. What's 3 take away 2?
1.
1. Now if I take away 2 again, we'll end up on the negative side.
Yeah.
And I don't want negative. So 3 and 1 is the only possibility. So they're either going to all be positive, all 3 of them be positive, or only 1. Is there any way that they're going to be two positive solutions? No. So if you were doing guessing and you found one positive, should you waste your time with any more? Well, you could waste your time because there could be all 3. But if you find a negative or imaginary, keep in mind there is no even amount here for the positives. Make sense? All right. Negatives. How many negatives? Thank you. How many negatives did we have?
0.
0. Now, if I take away 2, will I end up on the negative side? Don't want that to happen, so 0's it. All right. Now, it's going to feel a little weird right now because it's new and it's confusing. 3 is coming from here. 3 take away 2 is 1. That's as small as I can get. 0 is coming from here. That's as small as I can get. Question before I move on? Yes.
What was the take away 2?
What was that?
Take away 2 from 3. How'd you get the 2?
That's you're always going to take away 2. Always, until you get as small as you can get. That's Descartes' rule of signs. You get your number 3 and you're going to, like say it was 4, you would do 4, 2, 0. Whatever your number is, you just keep taking away 2 until you get to either 1 or 0, never negative. All right, imaginary. Here's how imaginary works. We know the degree is 3, so I'm going to end up with 3 solutions. So I'm going to cover this one here. If all 3 are positive and none are negative, how many could be imaginary? How many?
0.
0. Do you guys see how he got that? Okay. I'm going to repeat it. The question I asked is, if all we know we can only have 3 solutions because the degree is 3. If all 3 of them are positive and none are negative, how many could be imaginary? 0. Does that make sense? All are positive, none are negative. I can't have any that are imaginary because I can't have more than 3, and all 3 of them are positive. Do you see that? Okay, I'm going to cover the 3. What's the other possibility? That instead of 3, I have only 1. If 1 is positive, I still can't have any negative. How many have to be imaginary? There would have to be some. 2. So it's either 3, 0, 0 or 1, 0, 2. What? What is that? Okay, before I explain the 3 and the 1, I will tell you imaginary, you never decrease by 2 or increase by 2. You just use the patterns up here. Like I said, you use your positive and negatives. Another thing before I explain her, answer her question is imaginary should always happen in pairs. Imaginary, why? Like when you square root both sides, you get an imaginary solution. Don't we always put plus or minus in front? Or when you do Pythagorean's theorem, x equals negative b plus or minus the square root of. Imaginary solutions always come in pairs. All right? Okay, so where did the 3 and 1 come from? Can anybody answer at least where the 3 came from? This one right here? Yes? All right, where did the 1 come from? The minus 2. 3 minus 2 is 1. Now I could minus 2 again, but I end up negative, and I don't want any negative solutions. So I stop there, 3, 1. Where did the 0 come from? The second one, the 0. Right here? Because they're all negative, it never changed to positive. Negative, 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 I never changed. Yeah? So negative to negative, that's not a change. They're still negative. To negative, again, they're never changing. They're all negative.
Okay. But isn't isn't it 6x at the top and then on the bottom it goes to the minus 6x?
I see your question. It's not sign changes from here to here. It's sign changes across. Like from here to here, that's 1. From here to here, that's another. From here to here, that's another. There's 3.
Okay.
Negative to negative to negative to negative. There's none.
Oh, okay.
So I see your observation. Do you see the difference? So it's not from what we plugged in to what we end up with. It's across. It's this one right here that we're looking at.
Okay.
Okay? Did everyone understand that? Is there another question?
Could you explain the imaginary again?
Yes. All right. So we're going to, this is all we have so far. The one possibility is all 3 of them are positive. If all 3 are positive, can any of them be negative?
No.
No, there's a 0 there already. If all 3 are positive, can any of them be imaginary? No, it's not possible because the degree tells us the maximum amount of solutions I can have, 3. So they're all positive, none are negative, none are imaginary. Yep? You get it? All right, so I'm going to cover this one now. We already talked about that one and this one. What if only 1 is positive? We still can't have any negative because it's 0. So that means we have to have imaginary. How many of them would have to be imaginary? 2, because 1, 0, 2 make the 3. Got it? All right, let's try another one and see if it makes a little more sense. Questions on that so far? Yes?
So we know the maximum number is 3 because the biggest degree is...
No, oh, yes. Yes. This right here. The degree tells us how many possible solutions. Yes.
So like if you cover up the 3, you want the 1, the 0, and the 2 all to add up to what the maximum
Degree
number
is. Yes.
Okay.
Yes. How would this help us when we're solving? When we have this list of numbers that we came up with last week, and it's a smaller list than an infinite list, but it's still a big list. How does this help us? Right off in this particular problem, there's no negatives. So would you waste your time making any negative guesses? No. Got it? So that cuts your list in half right there. Plus or minus, all these numbers right there gets cut in half because all you're dealing with is positive solutions. Got it? All right. Number 2. Same thing. F of x equals 5x to the 7th minus 3x to the 4th minus 2x to the 3rd, wow, plus x squared plus 3x minus 6. And underneath it, I'll give you a second to finish writing it down. I'm going to write f of negative x, and I'm not going to do it like I did on the other one where I plugged it in. We're just going to go through and do it together. If I plug in a negative here, positive 5x to the 7th or negative? If I plugged a negative in here, minus 3x to the 4th or plus? Minus, because the negative when I raise it to the 4th becomes positive. Minus 2x cubed or plus? Plus 2x cubed. Plus x squared or minus? Plus, that negative doesn't change that one. Plus 3x or minus? And minus 6 or plus 6? Minus 6. All right, do you guys see how we did that? Any questions on how we got this plugging in negative x? Where was it at? Right here? Thank you very much. All right. What's our degree here? 7. So 7 solutions. All right. So again, you'll list positive, negative, and imaginary. All right, so I'm going to let you guys look at the positive sign changes first. Go ahead and do that. Anybody have it? 3 is correct. Would you like me to explain that?
Yeah.
So positive to negative, is that a sign change?
Yeah.
Negative to negative, is that a sign change? No, so right now we're at 1. The negative change to positive, is that another sign change?
Yeah.
That's 2. Positive to positive, is that a sign change? No, it is not. And then a positive to negative, is that a sign change? So how many was that total? 3. You decrease by what? 2. Even if that was a 4, it doesn't matter whether it's odd or even, you always decrease by 2. 3 take away 2 is 1. And can I take another 2 away? No, because they end up negative. All right, I'm going to have you look at your negative sign changes and see if you can figure out how many happen there. This does not count as a change. Negative to negative, that's staying the same. That is not a change.
Is it 2?
It is 2. Did we see that? Negative to negative, that's not 1. Negative to positive, is that 1? Positive to positive, yes or no? No. Positive to negative? Okay, that's the second one. And negative to negative, yes or no? No. So how many? 2 take away 0? Sorry, 2 take away 2 gave you the answer. Is 0. Does that make sense?
So you say subtract the 2 to all, even the imaginary?
Not the imaginary. The imaginary does not work that way. The only ones you take away 2 on are these. The imaginary work by adding up to the 7. And what do we say about imaginary? They should always happen in what? Pairs. 2, 4, 6, 8 is what I'm talking about, even. So let's just put the word even there, if that makes more sense. All right, and it should happen on its own. You shouldn't force it to happen. If it doesn't happen on its own, you've made a mistake somewhere back in here. All right, so I'm going to cover, there's going to be quite a few possibilities here, so please make sure you're listening. All right, first possibility. 3 are positive and 2 are negative. That leaves how many to be imaginary? 2. Okay, I'm going to go over that again. Why? Because 3 plus 2 plus 2 is what? 7. The degree is 7. All right, do you guys see that? 3, 2, 2. All right, now I'm still going to work with the 3, but I'm going to cover the 2. What if 3 are positive and none are negative? That leaves us with how many imaginaries? 4. Are they coming out to be even? All right, there's still more possibilities. Okay, so I'm going to cover this one and this one and the 2. All are 3 are positive. None are negative, and that leaves us to have how many imaginary? Because 4 plus 3 is? All right. I've exhausted the 3. I've done 3 with 2 and 3 with 0. Do you agree? Which one have I not touched at all? The 1. So I'm going to do 1 with 2 and then 1 with 0 and see what I end up with. 1 plus 2 is what? Plus what is 7? Is it already there? Okay. 1 plus 0 is 1, plus how many more to get 7? 6. Is that all of them? All right, so what did I do? I did 3 with 2, 3 with 0, then 1 with 2, 1 with 0. And the 1 and the 2 overlapped with the 3 and the 0. Make sense? It's confusing.
Yeah, I'm gonna get so confused because there's 3 answers and you said it's supposed to be in pairs.
Okay, by pairs I meant even. That's what I meant. So that's why I changed the word to even. 2, 4, 6.
Okay.
By pairs, it's because when you do plus or minus, it'll always end up in pairs. So 2, 4, 6. Never an odd number when you're doing imaginary.
Now do you have me thinking that we're gonna have like 2 answers only?
When I said pairs, is that what you were thinking in your head? No, no, no. I meant there's a pair there, there's 2 pairs there, and there's 3 pairs there. That's what I meant. Sorry. Even. So put in your head even. All right. We're good? All right. Questions on that piece? All right. We're going to talk about upper and lower bound. Did you guys do that last year, upper and lower bound? Who knows? Is that sounds familiar? Let me tell you this right now. You're never really looking for upper bounds. Where are you going to use upper or lower bounds? Two different scenarios. On homework, they'll give you a number and say, is this an upper bound? Yes or no. Or is this a lower bound? Yes or no. And you do the test and you answer yes or no. On the test, they may say this number is an upper bound. Okay, so you're never hunting or looking really for upper bounds. You may find one, and then you can use it on the test, and I'll explain what that means. All right. I'm just going to give you a list of numbers in here. We're just going to make up numbers. 2, -3, 1, 3, -10. Let's pretend this came from a polynomial. So that would be like 2x to the 4th minus 3x cubed plus 1x squared plus 3x minus 10. And we're checking to see if 2 is a solution. All right, are you ready? 2, because we dropped the 2. 2 times 2 is 4. What do we do going up and down? Add and subtract. -3 plus 4 is 1. What do we do with the 2 and the 1? Multiply, add. I'm going to have you keep going. And it does not come out to be 0. Did you guys finish already? 6, 9, 18, and 8. All right, so let's say this was a problem you're working on and you were testing to see if 2 is a solution. Would you say yes or no and 2 is a solution? No. No, it's not. Do you agree? All right, but what we do know is since this whole row is positive, do you see that? The 2, 1, 3, 9, 8, do you see that? Since that whole row is positive, since the whole row is positive, 2, this number right here is an upper bound. And I'll explain what that means. Okay, so you're not really looking for upper bounds, but if you find them, you can use them. Let's see if I can give you one from yesterday. All right, so let's say it was on this list here. This list right here. If we were testing it, in this case 2 didn't work because it wasn't all positive. But let's say we plugged in, let's say 3. Let's say we plugged in 3 and the whole row came out to be positive. That means no number higher than 3 would work. Does that make sense? It actually happened here. We plugged in 6. If the whole row come out to be positive, then that means nothing higher than 6 would work. So should you waste your time with 10, 15, or 30? No. So are you hunting for upper bounds? No. But if you're testing values and you come across this, should you stop and cross out all your numbers that are bigger than 2? Yes, positive numbers that are bigger than 2. You could still use negative numbers. -3, -4, -5 would still work. Got it? All right. So how does a lower bound work? -3, 5, 12, -8, 1, -2. Now I'm just using a set of numbers here that I've worked out ahead of time, but this number does not have to be negative. It is here, but it does not have to, nor does that one have to be positive. All right, drop your first. I'm going to have you guys, the last one does not come out to be 0. I'm going to have you work it out. All right, I have 4. Did you guys end up with 4? All right, if I was testing this for solutions, would -3 be a solution? No. How can I tell it's not a solution? There's a remainder. All right, but what do we notice about this row here? It alternates, positive, negative, positive, negative, positive. Now, it doesn't have to start with positive. Could it have been negative, positive? Negative, positive, negative. Yes. If it alternates, what does that mean about the number in the box? It's the lower bound. Okay, so we're going to put a note here. The row alternates signs. And what does that tell us? That the number in the box, -3, is a lower bound. Now, it doesn't mean it's a solution. It doesn't have to be a solution. It just means you should try no numbers smaller than -3. So, on the test, they will sometimes just give you freebies. They'll say -3 is a lower bound or +2 is an upper bound. If they just give them to you as freebies, you don't have to test them. You just take them and cross out any numbers bigger than 2, bigger than +2, and any numbers smaller than -3. And it makes your list even smaller. So we have tools now. Will this make our list smaller if they give us upper and lower bounds? Will this make our list smaller if we know how many possible positive, negative, or imaginary solutions we should have? Yes. Again, so these you're not looking for. They're either going to give to you, or when you're testing values, you just kind of pay attention to the pattern. If you notice they're all positive, or if you notice that they alternate, then you're saying, oh, that's an upper bound or a lower bound. Questions? All right. Let's try one. Okay, we're going to part A, use Descartes' rule of signs. Part B, list all possible rational roots. That's last week's lesson. List all possible rational roots. So I just want to remind you, when you see this on homework or a quiz or a test, list all possible rational roots. That's asking you for what over what. Do you remember the 2 letters we used? P over Q. All right, so make a little mental note because it will not give you that hint of, hey, remember it's P over Q. All possible rational roots, P over Q. All right, part C, find all zeros. All right, f of x equals 6x to the third minus 4x squared plus 3x minus 2. All right, underneath it, I'm going to write f of negative x. And I'm going to have you guys do that really quick. plug it in your head and just evaluate and see what it comes out to be. All right, positive or negative 6x cubed? Minus 4x squared or plus 4x squared? Plus 3x or minus 3x? Minus 2 or plus 2? All right, so when we, part A, list, used a card's rule of signs to list the possible positive, negative, and imaginary. That's part A. I'm going to do this, positive, negative, and imaginary. If that bothers any of you, then write out positive, write out negative, and write out imaginary. That is totally your choice. All right, where do I look to find the number of possible positive solutions? Sign changes on the original or the negative? The original. How many? 3. So 3 comma 1, because 3 take away 2 is 1. All right, how many sign changes on the negative one? 0. All right, I'm going to have you fill in the imaginary. What's the degree? 3. All right, so there's 2 possibilities for imaginaries. Fill them in. All right, what do we have for imaginary? 0 and 2. Do you guys see why I'm going to cover this? 3 plus 0 plus 0 is 3, yes or no? 1 plus 0 plus 2 is 3. Yes? And these are even like we said they would be. All right, part B. Any questions on part A? Part B. List all possible rational roots. Now, when we first learned this, I always said it's plus or minus, and then you list all your P's over Q's. Can anybody tell me why I'm not going to put plus or minus on this one? We already know what? There's no negatives. So we're going to cut our list in half and only be looking at what solutions? Positive. Some might be imaginary, but we know at least one is positive. Maybe 3, but at least 1, right? All right, so I'm not going to put plus or minus. I'm only going to list the positives. P over Q, what are the factors of 2? What are the factors of 6? 1, 2, 3, and 6. So I do 1 and 2 over 1, then 1 and 2 over 2, then 1 and 2 over 3, and 1 and 2 over 6. All right, and again, I don't need the plus or minus. So 1 and 2 over 1 is just 1 and 2. Do you agree? Then I divide each one, the 1's gone. I divide each one of these by what? By 2. So 1 over 2 and 2 over 2. Do I have that one already? Yeah, you can write it again. It's up to you. I'm not going to. Okay, I'm done with the 2. Now I'm going to do 1 and 2 over 3. So 1 over 3 and 2 over 3. Done with the 3. What's the next one? All over 6. So 1 over 6 and 2 over 6. What's 2 over 6? Do I have it already? Again, you can write it again, but I'm not going to. Is there a question how I ended up with this list? Yes? No? All right. What's that?
You just take the 1
Yep. We take 1 and 2 and divide it by 1, and then 1 and 2 and divide it by 2, and then 1 and 2 divided by 3, and then 1 and 2 and divided by 6. P, factors of P over the factors of Q. All right. I'm going to have you guys start to make guesses. That's part C. Find all zeros. I'm going to put the box and make sure all my x's are accounted for. Third power, second power, first power, constant. Are all the x's accounted for? All right, so what are my numbers? 6, -4, Okay, so we're looking for zeros. In order for a number to be a zero, what does the remainder have to be? Zero. So I'm going to give you guys some time to try. Just let us know if you find an upper bound, if you find a lower bound, if you find a solution, or even a number that doesn't work. So if you guys can try. Go. So again, you can shout out one, yes, just from this list. So you can shout out, so, you know, one doesn't work, or one does work, or did anybody try one? Trying it now? One does not work. All right, can you guys try two? So I'm going to put a little list here. One does not work. Two does not work, but what do you notice anything about the two? Is it an upper bound? Okay, so I'm going to try it. 6, 12, what's negative 4 plus 12? 8, 16, 16 plus 3, 19 times 2, 38 plus negative 2. All right, so it's not a solution, but is 2 an upper bound? Okay, so it's not a solution, but we're going to put a note, upper bound. Now, again, you're not ever looking for them, but when they come up, we're not going to guess any numbers bigger than 2. In this particular problem, are there any numbers bigger than 2? No. So it doesn't help us too much in this particular case, but if there were numbers, like say there were a 3 and a 5 or a 6, what could you do with those numbers? Cross them out. All right, keep guessing. 1/2, 1/3. 1. 1 was an upper bound. So then, okay, so when those of you that guessed 1, were all your numbers positive?
Yeah.
Okay, so could we have stopped here and not even wasted our time with the 2? All right, I didn't realize that. So number 1 they said was an upper bound. So should we have not even wasted our time with this one? No, we shouldn't have. But we did, and it's okay. Has anybody guessed a fraction yet that works? 1/2 does not work. You have one that does work? 2/3. All right, now people freak out. I don't like fractions, but we have to deal with them. I know. All right, 6, but luckily 2/3 times 6 is a number that we can handle. What is 2/3 times 6? That's 12 over 3 is 4. What's negative 4 plus 4? 0. 2/3 times 0. And then bring down the 3, because 3 plus 0. And then 2/3 times 3 is a solution. Is 2. This is 0. Is that a solution? Now, I have only one so far, 2/3. How many more do I need? 2. I will tell you this. Once you're down to all you need is 2 solutions, you can stop guessing. I'm going to repeat that. Once you're down to only needing 2 solutions, you can stop guessing. Here's another way you can tell. When this list is down to how many numbers? 3, you can stop guessing, and here's why. It was third power. 1 less is what? 2. So this is 6x squared plus 0x plus 3 equals 0. And you can always factor something that is x squared, whether it's difference of 2 squares, Pythagorean's theorem, complete the square. You can always solve something that has a degree of 2. So this is 6x squared plus 3 equals 0. Do you guys see that? Okay, so when can you stop making guesses? When this list is down to what? 3. Once it's down to 3, you can write it as a degree 2 polynomial and then solve with whatever method you can use. What method can we use on this one since it's just x squared? I can take out the 3 or I can subtract the 3. Do you agree? I'm just going to subtract it. And what can I divide both sides by? X squared equals negative 1/2. Now, is that going, what happens when I square root both sides? It's plus or minus imaginary, yes? I'm just going to write it down. X equals plus or minus I root 1/2. Yes? Right? Because 1/2 is not a perfect square, or 2 is not a perfect square.
Until we put the negative,
Yeah, plus or minus I root 1/2. Now, am I gonna list this as part of my zeros? No, so part C, what is my only zero? 2/3. All right, but what does that tell us about this situation here? It was either gonna be 1 positive or 3 positives. Which one did we end up with? 1, which means how many imaginary? And is that exactly what we ended up with? One real or 1 positive and 2 imaginaries. Does that make sense?
Yeah.
Questions? Yes.
When you said that when you end at 3, you stop.
Mhm.
Like 3.
Well, let's see, like if we had a bigger one over here. Like here. You started off with 1, 2, 3, 4, 5. And then we did it, the 2 didn't work, we did it with the 6, and the 6 did work. And we got the list down to 1, 2, 3, 4. And then you would guess another number here. We ran out of time, but you would guess another number. And you just keep guessing numbers until this list gets down to 3 numbers. So 1, 2, 3, 4, the next one would be your last guess. Because once you get them down to 3, you can write it as a degree 2 polynomial. We're going to get more practice with that for sure.
Is it once it's down to 3 and ends in 0?
Yes, once it ends in 3, and once it has 3 and ends in 0, because that means that number was a root or a solution, and then you can factor. Questions?